Hi everyone, I'm Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. So today we are going to do some numerical problems on half-wave rectifier. So in the previous session, we have discussed what is half-wave rectifier, and it is used for low power levels. And if you see, this is the circuit diagram for the half-wave rectifier. So this is transformer, and this is one diode, and this is load resistor. So during half cycle only, your diode gets conducted, and then remaining for the positive half cycle, diode conducts, and the remaining negative half cycle, diode off. So that's why this is the input and this is the output, rectified output. So based on this, we have different numerical problems models are there. So let us see one by one. So first one, a half-wave rectifier having a resistive load of 1000 ohms rectifies an alternating voltage of 325 volts peak value, and the diode has a forward resistance of 100 ohms. Calculate peak average and RMS values of current, DC power output, AC input power, and efficiency of the rectifier. So this is the basic model. So how to do this problem? First we have to take given data. So first given data is a half-wave rectifier. So half-wave rectifier means, so this is a half-wave rectifier. So first we have to draw the AC supply, and this AC supply has maximum voltage is 325 volts, and here you will have load resistor RL, which is given 1 kilo ohm, and across this we have to measure the output voltage and current flowing through this I. Okay. So here what we have to calculate, peak, average, RMS values of the current. First bit, A bit is, you have to calculate peak value, average current, and RMS current. So given data, first write given data. What is the data we have? So we have RL given, load resistance is 1000 ohms, and rectifies an alternating voltage of 325 volts peak, means maximum voltage given 325 volts. And then diode has a forward resistance RF, and that RF is given as 100 ohms. Calculate now peak value of current. Peak value of current, how to calculate? That is maximum value of the current. Im is equals to, so we have we know according to Ohm's law, V is equal to IR. So if you want to calculate I, it will be I is equal to V by R. Okay. So from this we can write Im is equal to Vm by, here we have to consider both RF plus RL. RF plus RL. So therefore, what is Vm? 325 upon RF plus and this 2. 1000 plus 100. So 1100. So 325 by 1100. So which you will get approximately 295.45 milliamperes. Okay. So the same way, in this first bit, we have to calculate average, I average, or we can also call it as IDC. So IDC formula, I is equal to V by R. So therefore, we can write VDC by, okay, or directly we can write the actual value. So we know the Im value. So if you derive for this, So this can also be written as Im by pi. After derivation, we get Im by pi. So directly substitution. So therefore, IDC is equals to, what is the Im value? This is 295.45 into 10 power minus 3 upon, what is pi? Pi means you will have 3.14 something, right? So if you solve for this, IDC you obtained is 94.046 milliamperes. And now next parameter we have to find is RMS current, that is called IRMS. So IRMS is half of the maximum value. The root mean square current is given by Im by 2. So that is, what is Im? 295.45 milliamperes, that is 10 power minus 3 amperes upon 2, that is equal to, so if you solve for this, RMS value, IRMS value is 147.725 milliamperes. Okay, so you can check by solving these values. Now the C value. What is the C value? B bit, DC output power. So DC output power, how to calculate? That is PDC. So we know power is equal to V into I square RL. So here we have to calculate I square. PDC means IDC square into RL. So what is IDC? IDC is this one. So substitute here. IDC is 94.046 into 10 power minus 3 whole square into RL. What is the value of RL? So here it is, RL is 1000. 1000 means you can write directly 10 cube. Okay. So here 94.046 whole square means whole square into, so 10 power minus 3 means 10 power minus 6, and here 10 power 3 is there. So this value becomes approximately 884.65 into 10 power minus 3. That implies you will get 884. So this will be 8.844.65 watts. Okay, so otherwise approximately 8.85 watts. So this is B bit. What about C bit? So I can write here C bit. C bit, what we have to calculate? DC power AC input power, that is PAC. So PAC can be calculated using the same formula I square RL. So that is here IRMS square into, here because it is AC, so we have to consider forward resistance of the diode also. So RF plus RL we have to consider. Therefore IRMS value, how much we got? IRMS value is this one. So substitute this. So what is IRMS value? 147.725 into 10 power minus 3 whole square into, so RF plus RL. So this is 100 and plus 10. So 1100. Or we can write this as 147.725 into 10 power minus 3. So this is here whole square. So this will be 6 minus 6 into, we can write this as 1.1 into 10 power cube, 10 cube. Okay. So therefore this value, so 10 power minus 6 and 10 power 3 becomes 10 power minus 3. And what is the value of this? This is approximately 2400.4, 4.94 into 10 power minus 3. So this can be written in terms of watts as 24.0 watts, that is PAC. Now, what we have to calculate next, D bit is efficiency. How to calculate efficiency? Efficiency is equals to PDC upon PAC, ratio of how much DC power delivered to the load and how much input power is there. So actually this is AC input power and this is DC output power. So PDC, how much we got? 8.85 watts upon, and how much PAC is 24 watts. So therefore, if you solve for this, efficiency is approximately 36.85%. If you multiply this, you will get in percentage, the efficiency is 36.85%. So this way you have to use general formulas to calculate the different parameters. Okay. So next, let us see the next problem, next model. A half-wave rectifier has a load of 3.5 kilo ohms. If the diode and secondary coil have a resistance of 800 ohms. So combination of diode resistance and secondary coil resistance is given 800 ohms, and the input voltage has a signal peak voltage of 240 volts. Calculate A bit, peak, average and RMS value of currents, DC power, AC power, efficiency. Same as in case of previous problem. Similar to this previous one. So we can do this problem using same concept. First, given data, load is given, load resistance 3.5 kilo ohm, right? If the diode secondary, so here diode secondary coil have a resistance, see here. So this is the half-wave rectifier circuit RL, and across this we measure the output voltage, okay, and current I, and it has RF, and here coil resistance is there, RS. So we need to consider all the three resistances of the circuit. So secondary resistance plus forward resistance of the diode combinedly given 800 ohms. Secondary resistance of the coil and RF is the forward resistance of the diode is combinedly given 800 ohms. What else given? So we are given peak voltage of 240 volts. That means VM is given 240 volts. Okay. So with this we can calculate peak average and RMS currents we need to calculate in the A bit. Under A bit, first peak means what? IM. So IM has to be calculated. So how to calculate IM? So in this case, IM current means, so you have to consider all the resistances. VM, I is equal to VM by RL. So here we have to consider RS, secondary coil resistance, and forward resistance of the diode, and load resistance. So we have to consider all the three. So what is VM value? 240. And what is RS? RS is given, RS plus RF is given 800 plus 3.5. So let us convert this 800 ohms into kilo ohms, that is 0.8 kilo ohm. Okay. So if you combine these two, RF, these three resistances, how we got? So we will get 3.5 plus 0.8 K. Okay. So that is 240 upon, this is 4.3 K, or we can write 240 by 4300 ohms. Okay. So that is IM. So if you solve for this, the value is approximately 55.81 milliamperes. IM maximum peak current we have got. Now average means what? IDC, average current means IDC. So IDC is equals to what? We know Im by pi. The average current through the half wave rectifier formula is Im by pi. So directly we can substitute this value. So what is Im? Im just now we got 55.81 into 10 power minus 3 amperes upon pi. So we get IDC is equals to, if you solve for this, IDC is approximately 17.77 milliamperes. You can check this using calculator. And next, RMS. RMS value is equals to, we know, Im by 2, half of the maximum current. So what is maximum current Im? Is 55.81 into 10 power minus 3 upon 2. So that is approximately 27.905 milliamperes. So this is the root mean square current value. So this is Im value and this is this one. Okay. And now what else we have to calculate? B bit. What is B bit? B bit is DC power output. So PDC we have to calculate. So how to calculate PDC? IDC square into RL. So what is IDC? So just now we have got IDC, this is the value. So 17.77 into 10 power minus 3 whole square into here RL. So what is RL value? So RL is 3.5 kilo ohm, or we can write 3500 ohms. So 3.5 into 10 power 3 I can write kilo ohm. So 17.77 whole square into 10 power minus 6 into 3.5 into 10 power 3. So if you square this value, so if you solve for this, we can directly get the value DC power output power as 1.105 watts approximately. Similar to this, the next is C. C bit is AC, that is PAC. AC input power. AC input power is given by IRMS square into RL. So that is approximately given by, what is IRMS? Yeah, 27.905 into 10 power minus 3 whole square into RL. So what is the value of RL? So 3500. So if you solve for this, you will get approximately 3.348 watts. Okay, this is PAC. Now the last parameter we need to calculate is efficiency. So efficiency symbol is zeta is equal to here PDC by PAC. So therefore, what is PDC? PTC, this is the PDC value 1.105 watts and PAC value is 3.348. So watts gets cancelled. So in percentage, approximately 33% you will get. So 33 point you will get. So similar to this, next model, let us see. A half-wave rectifier is used to supply 24 volts DC to a resistive load of 500 ohms and the diode has a forward resistance of 50 volts. Okay. So here forward resistance, this is printing mistake, this is ohms. A half-wave rectifier is used to supply. So given data, what is the given data we have? So max DC is given, VDC is given, that is 24 volts. This is VDC to a resistive load. A half-wave rectifier is used to supply 24 volts DC to a resistive load. What is RL? Resistive load means RL is given 500 ohms. And the diode has a forward resistance. RF is given 50 ohms. Calculate maximum value of AC voltage required. So AC maximum AC voltage means what? We have to calculate VM. So actually what is the value of VM? So we know V is equal to IR. So IM into RL. This is the actual formula. But we don't know IM. To calculate IM, we know the average DC current formula. IDC is equal to IM by pi. So from this formula, so what is IM? So if you take this pi this side, so IDC into pi. So what is IDC? We have to calculate here. So how to calculate IDC here? What is IDC? So here IM by pi. Okay. So therefore IDC can be calculated using this formula, VDC by RL. Because VDC is equal to IDC into RL, so IDC is equal to VDC by RL. So therefore, what is VDC? We have given 24 volts upon what is RL? RL is given 500 ohms. So therefore, here we can calculate, if you solve for this, IDC is obtained as 48 milliamperes IDC. And similar to this, here what we have to calculate? VM. So VM is equals to IM into, because it is maximum value of AC voltage. So therefore, we have to consider forward resistance of the diode also. So in such case, what is IM? IM value is approximately 150.8 into 10 power minus 3 into, this is 550. 500 plus 50, 550. So if you solve for this, the maximum voltage, AC voltage required at the input is given by 82.94 volts. Okay. So this way you have to calculate the value of different parameters of a half-wave rectifier. Okay. So I conclude here for today's session. So remaining will be discussed in the next session. Thank you.